Hi, my name is James Yu, and I'll be representing the Hotspotters, and this is our geothermal presentation. As an overview, we have structured our presentation in the form of key questions to consider when repurposing oil wells as geothermal plants. We will walk through the technical requirements and then layer on additional considerations, such as environmental impacts and social impacts. We will interpret and summarize this information for the viewer and recommend which wells are the best candidates to choose and describe areas for future investigation. To start, here are the four key areas we think are important to consider. The technical requirements such as will the site provide enough energy? How can we accurately assess the temperature of the oil well? Business development needs, such as what are some of the operational and technology decisions to consider? The social impacts, how does this affect people and how many people will the produced energy serve in the area? Environmental impacts, such as what effects will it have to the natural environment and wildlife? For starters, will the well provide enough energy? According to Lindell's diagram, any well that is 60 degrees or above would be viable for a binary power plant, and any well that's 140 degrees or above would be viable for a conventional power plant. So we are looking for any well that is 60 degrees or above. But it is not as straightforward as just simply using the temperature that we were provided, because the measured temperature uh, can vary wildly from the true temperature. So our second practical need is, how are we going to accurately determine the oil well's temperature? Well, to do this, we use an iterative process, this project pipeline, to build a more accurate and predictive model. Okay, to examining the information that we were provided, we were effectively looking for strong correlations to the true temperature of the oil well, which was a provided measure. And we looked for promising relationships. Four that were found were the measured temperature, as previously discussed, the subsea level depth, the latitude, and the longitude. In addition, we also noted specific features to individual basins that were also that also serve to enhance the model's accuracy. Okay, next, statistically treating outliers also improves model accuracy. What we did was group well by depth band size, so every 500 meters, and examine oil wells that reported figures that were either too hot or too cold. More specifically, we observed that the measured temperature indicated by the blue bars often understated the true temperature. So we adjusted lower outliers to the median value, which biased our model upwards and improved our estimates. As a result, our best performing model scored 3.65 on mean average error, and our best model applied the gradient boosting regressor to the basins individually. Okay. Next. To summarize the data analysis we produced temperature contour maps here to compare and contrast the two basins between Duvernay in Canada and Eaglebine in the US. The important conclusion here is that the US basin can potentially produce more energy at 151 megawatt electric compared to 56.7 in Canada. For more information on how we derive these two quantities, we put that calculation in the appendix of this presentation. Okay. Moving on from how we can accurately assess heat potential is the operational and technology consideration in this next slides. And there are two types of geothermal plant configurations, such as the open loop on the left and the closed loop configuration on the right, illustrated here. There are three considerations, and one is that the open loop configuration performs better in terms of heat extraction than the closed loop. However, an open loop configuration would likely require additional drilling and therefore additional costs. And thirdly, we will be generating this heat extraction by pumping colder liquids down the well and using the hotter geothermal heated liquid coming up from the well to power a turbine. Therefore, if the selected site is not sufficiently hot enough, we would need to consider using a lower boiling point liquid, which could add to the expense and compare relative to water. Okay. Well, in this next slide, we speak to the business needs of which are the hottest wells and which well provides the most amount of water, which are the two key and water flow, which are the two key components of operating a geothermal facility. And yeah, the dots shown here are the sites that we think are the best among all the wells that we were provided. Uh, of all the wells that we were provided, that would produce the most potential for geothermal energy. Specifically, they're in the prospect areas of East Edson and Fox Creek in Canada, and southeast San Antonio, and east-northeast in Austin. Okay, on to socioeconomic impacts. We determined that the Eagle Blind Basin has the advantage of a higher population in proximity, which could create the demand for energy and connect to a power grid that services a larger area. So 75,000 kilometers versus 26,000 squared kilometers. Although the U.S. Department of Energy has funded several research and development projects, there doesn't seem to be any significant political or regulatory advantage between the two basins in terms of potential job creation or tax benefits if we selected one over another. And lastly, the environmental impacts. The key conclusion here is that geothermal is an extremely green source of energy. It is also highly reliable as the source is available 24/7 compared to other green sources such as wind or solar. And we have research estimates that says operating a geothermal plant produces near zero greenhouse gas emissions, such as 50 grams of CO2 over a 30-year project lifespan. In conclusion, we touched very briefly on the business, social, and environmental impacts. So we have compiled this list of data points or information sources that we would like to have in order to build a more complete project. Thank you very much.